Hey guys, welcome back to our YouTube page. This is Mark from Northcomm Technologies. We have a new video today. It's been a few months since our last video. On the rack here today, you can see that we have a repeater. It's a Motorola Quantar. We have a link radio, and of course we have the SCOM 7330 repeater controller. We also have a service monitor here on the bench with an external display so that we can take a look at the spectrum analysis of what we're going to be doing today. The reason for that is because, again, this video is going to feature a demonstration of both analog repeat with one of our cables as well as the use of mix mode. But today's video is a little bit different than the last one we had featuring mix mode, because today I want to show you a new product, and this is our Centronics connector for the Motorola Quantar and the SCOM controller. Now, when I say SCOM controller, just understand that in our videos we use SCOM controllers, but this cable can be built by us for any controller that you might have. So that could be a Link, a CAT, an Arcom, or whatever else you have laying around the shop. Just to show you our new design, our new cables, like the old ones, incorporate the ferrite bead for RFI suppression. All of our cables always use UL listed communications grade cable, which is shielded and it has a drain wire. Amphenol HDP series connectors, molded power connections, and everything is fully shielded to reduce interference at the site. Even the Centronics connector is a shielded metal connector, and trust me, these are not easy to find. So for this video, we're going to show you how we connect this. It's very easy. I'm going to start by turning the rack around. So we have our standard connections that we're all familiar with on the back of the station. The one we're interested in today is right here. It's a Centronics connector J17. And to connect our cable, you're just going to loosen the Velcro. You're going to slide the connector in. Should hear a snap. Tighten down the Velcro, and you're all set. We get power and audio at this point, as well as all the logic connections that we can use for the wildcard tables. So this is really sort of a one-shot-does-it deal right here. I just put our cable up here. You can secure that with the supplied Velcro ties. We're just going to leave it there. It's a demonstration. So we're going to plug in our port 1. And lastly, we'll plug in power. And when we do that, we'll hear the repeater identify.
SCOM 7330 version 3.2.2.
Alright, and there we go. So obviously the repeater is working correctly. It's passing audio from the controller. Let's go ahead and turn this all back around and take a look at what we see. Alright, so we can see our spectrum display. We can see our modulation, test 1, 2, 3, 4, 5 on the service monitor. And as we can also see, as I just set this up, we can see that a couple of things. Basically that this is analog, 1. 2, we can take a look at the level of the signal coming in. This is an off-air signal, so obviously the measurements here aren't necessarily going to be too accurate. If we wanted to take real measurements for deviation and everything else, I would hook this up to our external time base, and we would take this right off the transmit port. But this is only for visual display. So, anyways, we'll notice that I'm talking in analog, but as I'm keyed up here, you'll see that on the Centronics cable, we have COR, push to talk, PL detect is the big one on this cable, and encode. Now, on the MRTI cables that we sell, you can control your PL, but you can't get PL detected at the MRTI point. And by control, I mean you can strip PL, or you can allow the repeater to receive a signal without requiring PL. Now that's normally a control left to the controller up here, but to the MRTI cable, we leave it up to the controller inside the Quantar. But again, with the Centronics cable, because we can write wildcard tables, and there are so many different settings in those tables, we can certainly provide a logic output like we have here to PL detect, and it's really not complicated. So that's one advantage over the Centronics cable, but that's not the primary advantage. The primary advantage is the ease with which we can do mixed mode communications. And really the key to this is leaving the digital audio inside of the Quantar and allowing the analog audio to pass through the controller. Now, you can do this and still have full control over your station. And the reason we can do that is because at the J17 50-pin connector, we can send logic signals to do things like transmitter inhibit and repeater knockdown, even when the repeater is passing P25 audio. So I'm going to switch over to channel 2 on our radio, which should be P25. Now, you should be able to tell by the spectrum analyzer that that's P25 audio. Well, at least you should be able to tell that's digital audio. And that carrier persists even as I'm not talking. And there you can hear the actual digital audio. And we'll notice a few things. The repeater is still saying encode, it's still saying PTT, and it's still saying COR on the controller. But what I want you to be aware of is that the controller is not passing the digital audio, and to prove that, I'll unplug the SCOM from power. Okay, I've taken power away from the SCOM, but the transmitter still goes into transmit mode, and receiver 1 is still active. And on our transmit frequency of 450.25, we still have a carrier signal going out. So you might ask yourself, well, what's the point of having a controller? Well, I'll show you. Let me plug the SCOM back in, and I'll show you the radio here.
SCOM 7330 version 3.2.2.
Alright, and what just happened is this P25 radio, which is programmed in mixed mode, still received our analog audio from the SCOM. Now, that's a great thing because when I key up in P25 and I let go,
4WCA repeater.
we can still hear all the PTT IDs, the CW IDs, and the courtesy tones. Now, of course, that relies upon your radio being based in mixed mode, and we want to extend the courtesy tone timer just a little bit in the SCOM to allow for that transition from P25 audio to analog audio, but it really works very seamlessly. Now, let's say, for example, you wanted to be able to shut this repeater down on P25, and we wanted to do it on analog through the SCOM controller. That's not a problem, because since we're going through J17, we can write a wildcard table, we can tell J17 a certain pin is programmed for repeater knockdown or transmit inhibit. And as soon as that logic point is enabled through the SCOM, the fact that this repeater is designed and would have been programmed to pass that audio regardless of this, it's not going to pass the audio, it's going to shut down. That gives us full control over the Quantar on P25 as well as analog. You retain your voice IDs, your CW IDs, and all the functions that you've normally had through an amateur radio controller, and you can do all this fairly seamlessly. And the most important thing to understand is that when you're doing the P25, by keeping the digital audio in here, we retain the astro-transparent forward error correction that's built into the Quantar. Taking that digital audio out and putting it through here would cause degradation in the digital audio signals. So these cables are available at my webpage. It's repeatercables.com. That's repeatercables.com. And if you have any question about this new Centronics cable or any of our other products, our phone number is listed on the webpage along with our email. Please feel free to contact us. We've sold over 100 of these cables. People have been very satisfied. And keep in mind, our return policy is just that. It's guaranteed. If you're not satisfied, we'll take it back, refund your money, absolutely no questions asked. Stay tuned for our next video. We're going to demonstrate the interface of a CAT 1000 controller into the Quantar using a linking radio for a customer who purchased this package out in Washington State. Thanks for watching. We'll talk to you soon.